Okay. Um, Now I've gone through all of test one, and I've reviewed for partial credit. Um, and the class average was already pretty decent when before that, but now with partial credit taken into account, I'm just going to take a look real quick. Um, the average, the mean score was an 80. Also, the median was an 85. So that means half the class got an 85 or better. Um, so, so as such, there's no need to apply a curve like I have in semesters past, which I expected because this time the uh, tests are not proctored and you have access to your materials. Um, so number of people got a score of 100, so or close to it. So nice job to all of those who did that. Um, Now, I do want to take a little time to talk about certain questions on the test where I noticed um, a number of people making the same mistakes. Now, if there are nearly 100 people in the class, there are only 8 of you in attendance now, and completely honest with you right now, because this is where I come from. No car. Please mute yourself before you join. Um, okay, so there's only 9 students here, and then I don't have a lot of data on how many watched the video afterwards, but based on what I do know, I don't believe it's everybody. I gave a review for the test beforehand, talked about the problems in detail, I gave a lot of advice, and a fair number of people did not follow that advice. So if not everybody's watching, there might not be any point doing this, but on the off chance there is, I'm going to talk about a few of these questions. So I'm going to share screen with a version of the test since the problems are randomized. Okay. Um, Now it's going to scroll through to talk about a few of these. Okay. Problems involving the slope. So a problem like this one gives you a graph, and it specifies 2 x values. So in this case, it's the x values are 1 and 5, and it asks for the average rate of change, which is the slope. So it's the slope of a line between these 2 points at x equals 1, x equals 5. So you subtract the y values, 29 minus 44 is minus 15, divide by the difference in x values, 5 minus 1. So it's minus 15 over 4. Change in y divided by change in x. I noticed some people had that backwards. And then if I could see some logic to what you're doing, and then whatever number you came up with, then I'm give partial credit. But in some cases, I had no idea where whatever number you were giving was coming from. So that's all it is. Change in y divided by change in x. Okay, this problem. You're required to basically multiply out this function or FOIL it, and then take the derivative. And what I noticed some people doing, it was enough people doing it that it kind of stood out to me, is that they took the derivative twice. Now, I did say in my review it is a 2-step process. Step 1 is you multiply it out or FOIL it. Step number 2, you take a derivative. Just take a derivative once. It's asking for just f prime here. So I was a little surprised by that. And then I would have to say that the most aggravating point losses of all Where for these questions here, multiple choice. So the problem like this is 2 steps. You're asked to interpret the value of the original function at a certain x. So in this case, the function is number of stolen bases per game is measured by this function, where x is the number of years after 1977. So here it's talking about just f, not the derivative, just plain old f. So now a lot of people would get the number correct, what it's asking for, but not the interpretation. So since it's only about the original function, the answer has nothing to do with any kind of change. It's just the expected stolen bases per game. So when it's asking what does the function represent, all you have to do is go back up here and look at what does the function mean? Number of stolen bases per game. And that's what is given here. And then the second step is about the derivative. So what does f prime represent? Well, whatever f represents is just the rate of change. Now, why I called this the most aggravating point loss is that I talked about this question during the review and about how it's, you have to keep in mind what is the interpretation of a derivative. It means different things. It means slope of a tangent line, instantaneous rate of change, or simply the rate of change. It does not mean the average change. I pointed out explicitly. It is not the total change. That's something else entirely that we'll see later. So I literally eliminated 2 of the choices for you, and then a large number of people picked this one, average change, or a few picked total change. It happened so often. I honestly felt like y'all were trying to spite me. It was just like and maybe all of you who were in attendance are ones who did very well in the test and did not make these mistakes. So great. But if any of you out here watching, out there watching, gave these kind of answers during for these questions, please pay attention, because these kind of questions are going to keep coming up. These are the easiest points of all to get. You have so many other problems that have very hard-earned points, where you're having to compute a derivative and use a product rule or quotient rule, whatever. That takes a lot of work. But here, this is something that's fairly quick. So, so don't be giving those points away. And this came up twice. Here are other ones that you're not have to compute anything. That part is given, but again, the same kind of interpretation. So, when it's talking about the derivative, it is not the average rate of change. Okay. It is also not the slope of a secant line. I never even talked about the secant line. In fact, average rate of change and slope of a secant line are the same thing. Here's derivative means slope of a tangent line. Okay, which line we're talking about is important here. Also known as the instantaneous rate of change, or simply the rate of change. If there's no prime, like in this part here, it's only asking about the original function, then look up in the problem what the meaning of a function is, and that's what you choose here. Or in this case, it's just the value of a function. It's not anything about a slope or a rate of change. Because it's not asking about f prime, it's only asking about f. So, and I will be bringing this up again when I go to review for test 2 and later for final. Hopefully this won't happen again, or at least not to this degree. Okay. So now, moving on to the next lesson, which is, so this week is 3.4a and 3.4b, where you're still computing derivatives, but now we're making use of those derivatives to better understand how the original function behaves. There are many cases where it's desirable to know when does a given function reach its minimum or maximum, and we're going to learn how to do that. And there are certain clear-cut business applications for this, because there are certain things you want to minimize or maximize, like maximizing profit or minimizing costs. Okay, so take a first step towards that today, and then today is about understanding when is a given function increasing or decreasing, because when a function changes between increasing and decreasing, then that's when you're going to have a maximum or a minimum. Like function goes up and comes down, and then goes down, then that means there's a maximum when it changes. Okay. So there's a few problems in this lesson that deal with a function that's given by a graph rather than a formula. So that's what we have in this case. So I want to zoom out. Okay. So it's asking you to specify where is this function increasing or decreasing? And the way Hawks wants the answer is it has a box for increasing, a box for decreasing, and you specify intervals in each box. Now, if a function is not exhibiting that behavior, for instance, this function right here, it's always decreasing. Now, how do we define increasing or decreasing? If x is increasing, so you're going from left to right, what's happening to the y value? So as I go from left to right along the x-axis, look at the y value. The y value is always decreasing. So this function is decreasing everywhere. Now, we don't see the graph for x past this point, but we just assume that it's continuing off in this direction here and then continuing as it is here. So here we want to specify that the function is decreasing on the whole real number line. So the way we specify that in terms of what answer you're going to enter. Okay, so it's increasing nowhere. So the what you'll actually enter to Hawks is this symbol, the empty set, so the 0 with a slash, and Hawks will provide a way for you to enter that symbol. So it's not a 0, it's the empty set symbol, so the 0 with a slash through it. If anyone say that it's decreasing everywhere, so on the entire real number line, this is what you will enter for your answer. So you must include the parentheses, as we're using interval notation, parentheses, and then left endpoint, comma, right endpoint. That's always the format. So if it's the entire real number line, it would go from minus infinity to infinity. And again, Hawks will provide a way for you to enter those symbols. So this is how you handle the case of a function that is increasing nowhere, decreasing everywhere. And a lot of answers in this lesson are going to be entered in this interval form, or in some cases there may be more than one interval that you enter, but it's always the same: parentheses, left endpoint, comma, right endpoint. Now the next problem is similar. So here again we have a graph, and you're asked to determine where is the function increasing or decreasing. And I found that a lot of students have difficulty interpreting what's happening in these graphs. So what we see here is, at first, for the left part of a graph, the function is increasing up until this point, and then afterwards it's decreasing. So we need to see what is the x value for this point where it changes from one to the other. And by looking carefully at the markings in the graph, we can see that at x equals 4 is where it changes over. Now the actual y values here are irrelevant. The question is asking for which x is the function increasing or decreasing? So if a function is increasing all the way up until x equals 4, and then decreasing from x equals 4 onward, how do you specify that for your answer? So the way you do that is this interval. So from the far left, if you will, of the real number line, all the way up until x equals 4, that is where it is increasing. So this is literally what you will enter into Hawks for interval in parentheses from minus infinity to 4. And then the rest of the real number line from 4 off to infinity, that's what you enter in a decreasing box. So you have to make sure in your answer that the entire real number line is covered. So in all of these intervals, the function is going to be either increasing or decreasing. So basically what you're doing is you're dividing up the real number line into these intervals and entering them into the answer boxes based on where a function changes from one to the other. Remember, you want to see what x value a change happens. Then that determines what these intervals are. All right. In other cases in this lesson, a function is, instead of giving it to you as a graph, it's given to you as a formula. Then you're answering the same question, where is the function increasing or decreasing? Right. Now, a key definition I want to make here, we'll zoom in now. Okay. Is increasing on some interval AB if its derivative is positive on that interval AB. Similarly, function is decreasing on some interval if the derivative is negative. So positive derivative is increasing, negative derivative is decreasing. So when f prime is equal to 0, that's when it might, I say might, change from one to the other. So to figure out when a function is increasing or decreasing, a helpful step is to find out where its derivative is equal to 0, because that is the dividing line between regions where it's increasing or decreasing. So what the problem asks for first is find x values that correspond to horizontal tangent lines. Now, what does that actually mean? Because remember, the derivative is the slope of a tangent line. Well, if the tangent line is a horizontal line, that has a slope of 0. So a function has a horizontal tangent line at a certain point if a derivative at that point is equal to 0. So really that's what you're looking for. Even though it doesn't say it that way, you're trying to find all points at which a derivative is equal to 0. So we go ahead and take a derivative. All right, so here the function is minus x squared minus 8x minus 18. So not much to it in terms of taking a derivative. So we're just using a power rule in each term. So we get minus 2x minus 8. So then what do you do? Once you have a derivative, you'll set that equal to 0. And you get this equation here. So now you need to solve this for x. So we'll just go through the algebra here. All right, so x turns out to be minus 4. So, and that is the only place where a derivative is equal to 0. So there's only a horizontal tangent line it was onto a new page. Okay. So we have a horizontal tangent line at this one point where the derivative is equal to 0. So now for the other part of a problem, it's asking where's the function increasing or decreasing? And the first part is helpful for that because this 1x value of a derivative is 0 divides the real number line into two intervals, and you can check each one to determine where it's increasing or decreasing. So what are the intervals that we now have? If you break the real number line up at -4, here are your two intervals, -infinity to -4 and -4 to infinity. So on this interval, the function has to be always increasing or always decreasing. Same with this one. Why? Because if the derivative is equal to 0 only at this one point, then it must be either strictly positive or strictly negative everywhere else. Like it has to be all positive or all negative on this interval. If otherwise, it will be 0 somewhere in between, and we've already excluded that. It's only equal to 0 at this one point. So what you can do is, all right, so you know it's all increasing or all decreasing on this interval, but how do you know which? What you can do is you can choose any x value whatsoever in this range, and substitute that into the derivative and see if you get a positive or negative result. Positive is increasing, negative is decreasing. Okay. So, and you don't pick one of the endpoints, but you can pick anything that's in between. So just as an example, I want to find out if f is increasing or decreasing on this interval. I need to pick some x value in here. So I just choose x equal to -5. Again, it's up to you. Whatever interval I have that's containing 0, I tend to choose 0 just because it's often a convenient value of x to work with. But 0 is not in this interval, so I have to choose something else. So now what I do is I take this -5 that I've chosen and substitute into the derivative. So the derivative is -2x minus 8. So I substitute it in there, and I end up with a positive value. So that says that the function is increasing on this entire interval because the derivative is positive at this one point in here. Therefore, it's positive on the entire interval. So derivative is positive. Therefore, the function is increasing. Now I check the other interval. X goes from -4 up to infinity. So I can choose anything I want inside that interval. I like to choose 0. It's convenient. It's often easier to plug in. So we end up with -8. So because it's negative, at this one point, therefore, f prime is negative on the entire interval -4 to infinity. So we say it's decreasing there. So in Hawks, in the answer boxes, it'll have one for increasing. That's where you put in this interval. And then one for decreasing, you put in this interval. Also, like after I've done this interval and found it's increasing, that does not necessarily mean it's decreasing after that. So it does not always alternate. So it's possible that I have a derivative equals 0 at a point, and the function is increasing on both sides of it. That can happen. So don't assume something like that. Okay. Any questions about classifying where a function is increasing or decreasing? Okay. Here for this function, same question: where is it increasing or decreasing? It's not asking about horizontal tangent lines, but you're going to end up figuring that out anyway in the process. So very first thing you do for a question like this, take a derivative. All right, so here we just go ahead and use a power rule on each term again. And like before, set the derivative equal to 0 and then solve for x. So just go for the algebra here, and we get -2. So that is the only point at which a derivative is 0. So now, typo. Okay. So here are the intervals you considered. So the real number line is divided at x equal -2. So now you're looking at -infinity to -2 and then -2 to infinity. So same idea as last problem. You're going to check a point in each interval. So for instance, from -infinity to -2, I could pick anything in here. I just choose -3. So we go ahead and substitute that into the derivative, 6x plus 12, and you get a negative result. So a function is decreasing on this interval. And then we go ahead and for this interval from -2 to infinity, 0 falls in this interval. So I'll go ahead and substitute it in. And we get a positive result. So a function is increasing on an interval. So the final answer that you put in a Hawks is increasing on -2 to infinity, decreasing on -infinity to -2. Yes, I made a shot. Now, here's another one involving a graph. So again, going to specify intervals where a function is increasing or decreasing. You're just not working with a formula this time. And what we have here is as you go from left to right, so as x increases, what happens to the y value? As I go from left to right, here the y value is decreasing. So up until x equals -5, it's decreasing. Then I'll zoom out here. Okay, so after x equals -5, actually, let's do that. Oh, yeah, I do. Okay. Then the function starts increasing, keeps increasing until this point. Look at the x value. All right. So the fact that the y value here is 4 is utterly meaningless. It's where in x the increasing stops. So at x equals 1, there's no more increasing, and it's decreasing after that. So here I've just typed out what has been observed, just in words, from the graph. But now, what needs to be done is translating that into interval notation. So it is increasing only on this interval. So from x goes from -5 up until x equals 1. So in Hawks, in the answer box for increasing, this is the interval that you would type in. And then for the other problem, for the other part where it's wanting to know, you input where it is decreasing. You have two intervals to specify in this case. Okay. And the way you would specify the answer, I'll edit this to reflect that. You'd specify these two intervals. So just put a comma in between in the answer box. So minus infinity to -5 in parentheses, comma, and then the next interval from 1 up to infinity. And so those are the intervals where it is decreasing. So here and here. And notice the entire real number line is covered. So we have minus infinity to -5, decreasing, -5 to 1, increasing, 1 to infinity, decreasing. So you think these intervals being chained together that cover everything through either increasing or decreasing. All right. All right, here we have a function that is a cubic. And like before, you're asked to find where there are horizontal tangent lines. And if there are no such values, it has a radio button for none, and that's what you would choose in that case. All right. Then after we have that information, we'll see where it's increasing or decreasing. So go ahead and take a derivative. Again, just using a power rule. For an SF function, so it's easier to take a derivative again. But those other nasty functions will come back, I assure you. Then set this equal to 0. So now we have a quadratic equation. So you can expect to do some factoring here. Notice that you can factor 3 out of every coefficient. Because we have a -3 for the x squared, I'm going to factor out a -3. And what's left is, notice all the terms are negative. So when I factor out -3, now all the terms are positive. X squared plus 2x plus 1. And that factors out nicely to be a perfect square. So we have x plus 1, the whole thing squared, is equal to 0. So now we just need to see where this factor is equal to 0. So that means that you're just going to get x equal to -1. So that is the only point at which there's a horizontal tangent. Now, because the original function is cubic and therefore the derivative is quadratic, there's always a possibility of having two values at which there's a horizontal tangent, but in this case, it turns out to only be one. So that's the x value that you would enter as your answer for the first part. Then for the second part, we check where it's increasing or decreasing. So these are the two intervals to consider by dividing up a real number line at x equal -1. Now, I'm going through the same motions here of choosing an x value and substituting in, and I get something negative in this case, and we say it's decreasing there. And then for the other interval, from -1 to infinity, for convenience, I just choose x equals 0, and I again get a negative value. So it's decreasing on both. So remember what I said, don't assume that if you find it's decreasing in one part, it's increasing in the other. You don't know that. So it's increasing nowhere because it was not increasing on either interval. For the answer, what you put in a Hawks is you join these together. It's decreasing everywhere. So you can say from -infinity to infinity. Now, I will point out that if you were to simply enter these two intervals in for Hawks, I'm not sure. I don't remember when this has happened, if Hawks might mark it wrong. However, if this is what you put in on a test, when I review for partial credit, I will mark it fully correct. So don't worry about that. Okay. But I want to point out before I move on from this problem that to save yourself a little bit of time in algebra, if we look at the derivative before plugging anything in, after you've factored it, so you have -3x plus 1 squared. So here's the derivative in simplest form. Notice, well, x plus 1, the whole thing squared, that's always going to be greater than or equal to 0. It cannot be negative. And you multiply that by -3. So this derivative is always going to be less than or equal to 0. So you can tell that just because of this being squared. So without even plugging anything in, you can tell that. So you can conclude at this point that the function is always going to be decreasing. So if you recognize that, then you don't have to go through these steps here. So something to think about that in certain cases might save you a bit of time. Here we have a function of a different sort. We have a quotient. So it's asking for horizontal tangent lines again. So go ahead and take a derivative. And that is going to require the quotient rule. So bottom times derivative of the top minus top times derivative of bottom over the bottom squared. So then we want to simplify that as much as possible. So we have x and minus x, those will cancel. Then we'll get -8 minus a -4, so -8 plus 4. And this is what we get. Now, quick lesson on determining when a function is equal to 0, because that's what you want to do. You want the horizontal tangent line. That's where a derivative is 0. So if you set this equal to 0, to find out where it's equal to 0, and it's a fraction, only check the numerator. The denominator is not relevant for that case, because if the denominator is ever 0, that means the function is undefined there. You want to find where it's equal to 0. Well, the numerator here is just -4, but the numerator is never going to be 0. So there are no horizontal tangent lines. So the answer in Hawks, you'd select the radio button for none. So then, the next part of the question is, where's the function increasing or decreasing? Well, we can answer that just by looking at this. The denominator is never going to be negative. Whatever you plug in here is going to be 0 or positive number. The denominator is negative. Therefore, the whole derivative is never going to be positive. So either it's going to be undefined at x equals 8, Otherwise, it's going to be negative everywhere else. So if a function is decreasing on the entire real number line, so it's increasing nowhere. So you put in the empty set in that case. All right. So keep in mind when you have perfect squares in your derivative, that may be useful for quickly determining whether a derivative is going to be always positive or always negative. So you can conclude that the function is always increasing if the derivative is always positive, and then decreasing if it's always negative. Okay. Gotta have a word problem. Here we have this function that describes revenue, where x is the number of units. That could be anywhere between 0 and 5,000. So this is the domain of your function. So your intervals are going to come not from the entire real number line, but from 0 to 5,000. And you'll see what I mean when I get to how you specify the answer. So how you proceed is like in the other problems. So you go ahead and take the derivative. And we just get this from using a power rule. And then set that equal to 0. So then you'll go for the algebraic motions here. And we get a result of 3,358. So at 3,358 is where the derivative is 0. So that's where the only place where you might have a change from increasing to decreasing or vice versa. So that tells you which intervals to consider. So notice we started at 0, not minus infinity. So 0 up to 3,358 is the dividing point. And then from that point, 3,358 up to the upper limit of 5,000. So be sure to take these into account when specifying your intervals. So unlike before, you're not looking at the entire real number line. You're looking at only this portion. And now it's divided at 3,358. Okay. So now, like before, you're going to check these two intervals. And that process is no different from before. So I just pick anything I want in this interval. So I just happen to choose one. Then I like plugging in 1 to polynomials because, like this one, because then all you're doing is you're summing up the coefficients. And that's what we get. In this case, we get a positive value. So the revenue is increasing on an interval. And then the other interval from 3,358 to 5,000, I could pick any x in between. So I just choose a nice round number like 4,000 and substitute that in. And we get a negative result. So the function is decreasing on an interval. So that's what you enter for where it's increasing, where it's decreasing. Last problem, we're looking for horizontal tangent lines. So again, we're looking at where the derivative is 0. So here what I do is use a general power rule. I pull the 2 down, the exponent, and then I have this raised to the first power. And then I take a derivative of what's inside here, which would be minus 3. And then I go ahead and condense that, and this is my derivative. Of course, you can take as minus 6 and distribute, but in this case, I found it easier not to. And the reason why is I now need to set this equal to 0. So since I have this factor of -6, but obviously it's not going to be 0, I can focus only on this. So if you know from a problem that you're going to take the derivative and find out where it's equal to 0, if a derivative is already in some factored form, you generally want to leave it that way, because then you can look at each factor individually and figure out where it's equal to 0 to find out all the points where it's 0. If it's not in factored form already, then chances are you'd want to factor it. Okay, so then I can just take this factor here and set it equals 0. Or another way to think about it is I'm dividing both sides by -6. So then I go through the steps here, and I get -8/3. So that is the only x value at which a derivative is 0. So that is where the function has a horizontal tangent line. So then I get two intervals to consider. At -8/3 is where we divide up a real number line. So like before, we need an x value in each interval. So this interval goes up to -8/3. So that's minus 2.6666 repeating. So x equals -3 falls in this interval. But again, I could choose any x value that goes in here. So then I substitute -3 into the derivative. And then we get a negative value here. So a function is decreasing on that interval. And then for the other part, -8/3 up to infinity, I can again pick any x value and choose 0. And it's increasing there. Okay. So we see the intervals where it's increasing and decreasing, and that is what gets entered into box. All right. So generally, something like this where we have a just this perfect square here. So that function is always going to be non-negative. So we only equals 0 at 1 point, which is also -8/3, and then it's positive everywhere else. Now, as this is a quadratic, you would know from college algebra that this is a parabola, and parabolas always behave the same way. That they either, depending on the coefficient of x squared, they either go down and come up, like if the coefficient is positive, or go up and come down, if the coefficient of x squared is negative. So, keeping in mind what you know about quadratic functions and how they behave. So, if a function given to you is a quadratic, then that gives you an idea of what to expect when it comes to indicating whether a function is increasing or decreasing. Now, so I mentioned that with general functions, you need to be careful. Don't make assumptions about them. When it's a quadratic, we know enough about their behavior. People say, okay, it's always decreasing, then increasing, or the other way around, depending on the coefficient of x squared. But higher degree functions like a cubic, there are more possibilities in that case, and it's best not to make assumptions about what you'll get. So I'm just pointing out certain potential shortcuts. But we see that how you proceed from this lesson: find a derivative, find over derivatives equal to 0. That divides up a real number line into different pieces, and then you use any x value within each piece to plug into the derivative, and that tells you whether a function is increasing or decreasing on that interval. And depending on what you get, that's where you enter that interval into Hawks to classify a function as increasing or decreasing. Are there questions about these problems? Okay, I will end the recording at this point.